So this is the Heliodon that we have made at the College of Architecture. And I'd like to walk you through the different parts of this Heliodon. Okay, so the first one would be the monthly rings. Okay, so this stainless steel, there are 7 rings. They represent a particular day of, of each month. So for example, here you would see June 21. Okay, so this outermost ring to the left, to the north, would be June 21. Okay. Then the next one would be July 21. And then guess what? Okay, it's August 21, and then September 21, October 21, and then November 21, and the last would be December 21. For those of you who are a bit familiar with these dates, June 21 is the summer solstice. It's the longest day, okay, the longest daytime. And then the middle one, the September 21, and incidentally, it's also the same as March 21. It will be the equinox. So there will be 2 equinoxes, one happening in March and one happening in September. So there's a distinction between them so that you will know which equinox you're talking about. Then the last one would be December 21. Okay, this one. December 21 would be the winter solstice. So all of this. Okay, now this yellow marks, they represent the time of the day. So essentially, the day starts at 6 o'clock. Okay, and then the first mark that you get is 7, and then 8, 9, 10, 11, and then you will reach the noon. Okay, noon time. This arc here, it represents the noon, and then 1 o'clock, 2 o'clock, 3, 4, 5, and then 6 again. That's sunset. So these are the hours. Okay, uh, they are supposed to align, but they are not quite aligned. Okay, now so this flat surface is what we call the work table. It actually represents the ground. Okay, this is a representation of the solar paths, but in this is quite out of scale in reality. Okay, so this is what this Heliodon does would be to somehow emulate as you move northward, then this ring has to be tilted. Okay, one notch one notch is 5 degrees. Okay, so see that pointy part. Okay, it's five degrees. Okay, so let's you would notice that the solar angles have not turned much. Okay, 5 degrees seems to be very little to find something meaningful. Okay, but that's how it is, no? From the equator to 5 degrees, perhaps that would be Jensen. Okay, Jensen. I don't know. Approximately that's 5 degrees. Okay, Davao City would be 7, so it would be somewhere here, and then Cagayan maybe 10. Okay, so this one would be 15. Okay, so for example, latitude 15. Okay, so this would be the path of the sun for latitude 15. Okay, so one very important thing to note here is that in the tropical region, the sun will always be passing overhead once or twice a year. Okay, so but you see that you can imagine now uh, that the sun will be very southwardly, okay, southwardly uh, when when winter solstice come. Okay, now let's take it a bit further. No, so for example, you are not in the tropics. Okay, so the tropical region will end 23 and a half degrees north and 23 and a half degrees south. So let's move the dial. So this is 15, this is 20, and this is approximately 23 and a half degrees. Okay, so you notice now that the June 21 will be the only time that the sun will be overhead. That's once. Okay, so why are we very concerned of the overhead? Because in the tropics, the sun, the intensity, the intensity or the effect of the radiation of the sun depends so much on the angle that it has with the surface of the earth. The closer it is to 90 degrees, then that will be the highest intensity. Therefore, the hottest. When it's December, you notice if it's December, you can see it from the side, the sun angle will be very, very low. Okay? I don't know, maybe less than 40 degrees. Okay, but in December, so that's why in December it's much cooler. Now let's go beyond the tropical region. Okay, so something this is now 23. Maybe this is 25, then 30, and maybe 30. 5. Okay, so this is latitude 35, and now you would notice that the sun, the solar angle would be very, very much lower or less steep compared to how it was during in the tropical region. Remember when this was still at latitude 0. Okay, now let's tilt this rings. So as you go further to the north, the relative position of the sun would be going down to the south. Okay, so the moment this December, that December ring will be on the horizon, is is the beginning of the Arctic Circle. Okay, so here you notice that during summer, during this June 21 ring, you notice that the time of sunrise would be uh, approximately, would be very early. Okay, 6, 5, 4, 3, maybe at 2:30, you will already have a sunrise. Okay, and then you will have a very, very long daylight. Okay, until it sets somewhere, sometime in um, 6, 7, 8, maybe 9 o'clock. Okay, so the sun will be below the horizon in just a few hours. Okay, now let's take this further. But okay, but the other side, like during winter, during December, the sun would be available. Since this is Arctic Circle, in December, the sun will be available not at all. Okay, the sun will not be available at all. Okay, there will be no sun during the winter solstice, but during summer solstice you have plenty of sun. Let's go further to the north. Okay, so it will be in this position. You see that the sun will be just turning around and around where the sun will never set. Okay, will never set at all. Okay, so June, July, and almost the month of August, there will always be sun. But September down to December, there will be no sun. It's always nighttime. So let's go back to the tropical angle. Okay, you will know that you are in the tropics if the sun is the solar noon is above you. Okay, you will know that you're no longer in the tropics when there is no solar noon, no sun at noontime above you. Right there above you. So now what you can do now is having known these things, is you can position, like if you have the possibility of repositioning the building in some kind of an orientation, then you would be able to imagine easily how it would respond to the different times of the day and different days of the year. So that's it. That's how this Heliodon works. And thanks to Norbert Lechner for sharing his design of this Heliodon to us.